Hey guys, welcome back to AlgoYogi. We are doing array and hashing series. So next problem in the list is monotonic array. Let's go to lead code. There we are. An array is monotonic if it is either monotone increasing or monotone decreasing. So an array that's nums is monotone increasing if for all I less than j or equals to j, the num at I is less than or equals to nums at j. An array nums is monotone decreasing if it's the other way around. So for all I less than j, nums at I is greater than or equals to nums j. So really simple. We are checking if the array is either increasing or it's decreasing. And by the word monotone, they're saying that they haven't used the word strictly, so that's why like equal values are allowed. Let's say in this first example, this is true because 1, 2, 2, 3, it's monotonic increasing, right? So given an array, nums return true if the given array is either monotone increasing or monotone decreasing, otherwise you return false. So let's do that. It's a simple problem. All right, so I've taken the first example here. We are given nums. Now, as the conditions for monotonic increasing or decreasing, stated in the problem description, it's basically we need to check is increasing, right? Or monotone. Let's mark monotone. Is either monotone increasing or is monotone decreasing? This is what we are checking, right? So in this particular example, if you see that all these values are increasing, although since it's not the problem hasn't asked us to check it strictly increasing, that is why this is allowed. So this nums array right here, it's actually monotonic increasing array. All right, so this is monotonic increasing. Well, there could be another example that could be given this way. So 3, 3, 2, 1, and 1. So this array would be monotonic decreasing array. This is monotonic decreasing. All right, so basically if you look at the graph here, this would be basically 3, 3, right? 3, 3, and then 2, and then 1, and then 1. So this graph would look something like this, right? Or you can keep going like this. So it's monotonic decreasing. The graph has never gone up, from this any previous value. It's not just neighboring previous value, it's any previous values. So what I mean is, in our condition, if you remember, I'm just gonna remove this. If you remember from our conditions, we were told that for monotonic increasing, for all the I less than j or equals to j, all the nums at I have to be less than or equals to nums at j. That was the condition here, and for this as well, for all the I less than or equals to j, nums at j will be actually greater than or equals to nums at I. Yeah, nums at I. So I guess you can see that. So these are the conditions that we need to follow, right? So what we can do is, since we have to compare all these values, so it would be okay to compare the neighboring values, because at any point if there is a value that is actually causing something to become not either monotonic increasing or decreasing, then I think we can compare it with the neighboring value, and we should be able to find that out. So what I'm trying to say is, let's say this one is monotonic increasing, but if there was some value that was making it monotonic decreasing, that would be something like 2, and then here I write 4 and 2 and 3. So I don't have to check this 4 to all the previous value, right? Or any values that are going to be, you know, in front of this 4 to check, you know, some bigger values has appeared in middle of two values. I can just simply check it with its neighbor, right? If it is like messing up with the flow, although at this point it wouldn't be the best choice to compare it, but this would be the best choice, because if it were supposed to be monotonic, then this wouldn't exist. This would not exist, because my nums at I was strictly supposed to be less than or equals to nums at j, right? If these I and j exist, which it does, then this needs to be followed, but in this case it's not followed. So what I'll do is I will maintain two variables. I will maintain is increasing and I will maintain is decreasing, two variables, 1 and 2, and in single pass I will basically go over all the values for I in range from 1 to length nums. And the reason I'm starting at 1 is so that I can actually start with the first index and compare it with the previous value, right? So I will say if my nums at I minus 1 is actually, if this I minus 1 is greater than nums I, then what's happening is this cannot be monotonic increasing. So I will make this false. Okay, make this false. Initially I will start both of these values as true, right? I will start them as true by default, but I will update them here if I were to see this, because in this case it cannot be monotonic increasing, because I'm seeing a bigger value before I. So previous value at the ith index, the previous value was greater than the ith value. And there is another thing that I'll check is for is decreasing. So I will say nums at I minus 1 if I minus 1 is actually smaller than basically nums at j. Sorry, j is basically I. Okay, if this is smaller, then my is decreasing will be false. They could be equal, by the way. They could be equal. These neighboring values could be equal. That doesn't disqualify them from either being monotone increasing or monotone decreasing, because they haven't used the word strictly increasing or strictly decreasing. DECREASING. So this becomes false. And in the end, I can just return either of these, so either of these. So return either of these two values. Okay, so either of these two. Yeah, that's what you return. Okay, so let's talk about the time and space complexity. So time complexity of this solution would be big of n, and n is the size of the nums. And space complexity will be constant, because we are not using any space. We are using just two variables to, two flags to store the boolean values. Okay, so now we can jump into the solution. Let's code it up. It's an easy solution. Nice. Okay, so as I said, is increasing is decreasing, two variables. We are starting both of them by default as true, and then we also return either of these. So if any of them is true, then makes the array monotone. All right, so this or this. So I'll just use the word or. Simple. Start the for loop for I in range, starting from 1 to length of this nums, and then if the value at nums I is actually if it is let's say smaller than nums I minus 1, that means I was supposed to see a greater value or equals to value, but I'm seeing a smaller value at I, then that means it could not be increasing anymore. So I will assign this sign false because that condition has gone away, right? It could not be increasing anymore, but it could be decreasing so far. But let's check for that as well. So we are checking for inequalities here, right? We are not checking for truthness. We are checking if something, that condition becomes false, right? We are not checking for the truth. We're checking for false. So here, if nums at I, it was supposed to be decreasing, but what if it's increasing? If it is greater than nums at my I minus 1, previous value, if that's the case, then my decreasing becomes false, right? It becomes false, and then I end up returning this. So that will be the entire code. It's an easy peasy, really simple code. So let me zoom out and try to run it on the example cases. And great, so that runs. So let's submit it. Awesome. Time and space complexity. Time complexity we already discussed is big of n is the size of the array, and space complexity is big of 1 constant because we are not using any space. Alright, so we're just iterating over the array and checking if it is, if it cannot be either increasing or decreasing. So let's go back to AlgoYogi, mark this problem solved. See you guys later in the next problem. Bye-bye.